Okay, welcome back to Ox Tools. I'm Tom. We got kind of a weird job here this afternoon. I have to bore a round hole in kind of an odd-shaped object. I was going to do it on the mill, but then I started looking at it, and the size of the hole in relation to the boring heads and the tools that I have for the boring heads is kind of right in that funny spot where it's a pain in the neck. The hole's 3.75 in diameter, and it's in a funny shape formed stainless steel sheet metal piece. So it's 1/8 inch stainless. I welded these pieces on here to extend it. The guy I'm doing this for, they need a larger hole in this, and it's just a little wider than the width of this, so I added some little skirts onto the side, and I'm going to open this hole up here in the center to 3.75 plus a little bit. Like I said, I was going to do it in the mill, and then I was like, geez, I looked at the boring head and I wasn't liking the look of that, so I decided I'm going to do it in the lathe. So how do you hold that in the lathe, right? That's kind of a funny shape to hold. Well, I have these some face plates that go in the lathe that so you can put a regular face plate on the lathe, but that means you got to dismount the chuck and hoist that thing off of there, put the face plate on there, get all the clamps together, etc., etc. Well, what I have is some small homemade face plates. This just has an array of tapped holes in it, and then for that I've created some small strap clamps. So I got a couple different sizes, and these are just like your mill strap clamps here, but these are kind of miniature versions. They're set up for number 10 screws to hold small parts, and so I use them all the time. You got some tiny little part that you have to hold, and you're going to crush it in the vise, and you can use a smaller vise, but sometimes that isn't right. Sometimes really all you want to do is just kind of hold the part down, and then you can do whatever it is that you have to do to it, and holding it down is the safest way to hold it. You don't want to squeeze it, you don't want to put it in a collet and compress it. You just want to push it straight down. A lot of times that's a very, very safe way to hold things. It's just kind of straight down, where they're just between the clamp and the basement, the base plate. So anyway, that's what I'm going to do on this guy here. And so I got a 6-jaw chuck on this, big 6-jaw chuck, and a little trick you can do to hold square things. And what I want to do is I want to put this in, since I don't want to dismount my chuck, and put a face plate on, and have to deal with these little number 10 screws for these clamps. So if you just remove 2 jaws here, then you can clamp some square things in it. So I've already taken the 2 master jaws off of these opposing jaws here, turned the other master jaws around, since this thing's kind of large, and now I'm just going to tighten these up and put this thing in there. So this is an argument for having a 6-jaw chuck. Everybody goes for the 3 jaws because they're generally cheaper, but 6 jaw is actually a really nice chuck, especially when you get into these bigger ones. They hold, there's just more points of contact, so they don't crush tubes as much. I don't know if anybody out there has experienced if you grab a thin wall plastic part in a 3-jaw, then you bore it, then you release it, you end up with this kind of lobe bore or lobe OD. from the 3 jaws. Well, this 6 jaws gives you less space between the jaws, so you don't have to hold as hard, and it's closer to circular. It's one step closer to a collet. That's maybe a good way to think about it. Okay, so it's back in neutral. I'm gonna put this guy in there. You can see it's just spanning that deal there, and I'm pretty sure I got a hole in the center. It really doesn't matter because I have to indicate the part. I'm just gonna put that in there like so. Okay, crunch it down a little bit, and those corners are biting in there real nice. Okay, so just for good machinist practice, I'm gonna give that a little tap. Just to make sure it's seated real well. So what I'll do now is I'll actually take a little facing cut across that, and then now I'm square with the machine axes. And then what I'm going to do is this part will get mounted on here like this, and I'll just use these toe clamps in a bunch of places and hold it down, and then I can bore my hole. So I got a nice hole here I can indicate on. Actually, I just thought of something. What I'll do is I'll go ahead and once I face this off, I'll put some little score marks on here to help me get this thing lined up a little closer. So let's go ahead and do that. Get this out of the way. So yeah, I made a whole little kit, and it's got screws, and it's just like a mill clamping kit. It's a miniature, and it all fits in this little case. All right, let's set that aside. All right, what speed are we in here? We're going to be in that speed right there. See it, but that hole's not quite in the center. Well, hey, that's pretty good. That's a little outside the. I suppose I can back that up. There. Alright, that looks okay. I always like to zero the compound if I move it, just so I know. If I, it's right in the work area there. Sometimes you bump it and you go, oh, geez, where was it? So I always try to reset it on 0, when I'm not using it. And then I got to change the feed here. That's just touching now. So let's try 15 thousandths. Oh, the feed's too slow. So these face plates, you can face them off multiple times. They start out an inch thick or something like that. And I've had this one for quite a few years, and it's only 800 thousandths. It's only down to 800 thousandths now, and so they last a long time. underneath here, and this looks like it's going to get kind of close here, so I'm going to go ahead and stop that right now. Yeah, I don't think it was going to make it all the way across, so I'm going to go ahead and move the tool post a little bit. Swing that around like that. That'll give me a little more pizzazz there. Alright, something like that. I don't really like that finish either, so I think I'm gonna increase the feed even more there. Shift to the higher feed, and my WD-40, where is it? I see it, okay. Give that a little spritz. So you can hear that feed now. Another 5 because I've already got 15 in there. There we go. Now we're talking. That's 500 RPM, and the feed rate's I don't want to look at it. Again. Probably 15 thousandths per rev or something like that feed rate. Yeah, looks pretty good. Okay, so what I'm going to do now is I want to put a little, a couple of witness marks on it, just to help me line up my circle. So I don't need that high feed rate anymore. Let's back it out. Let's see, what do I want to do there? You know what? I think what I'm going to do is I'm going to move this off here. I'm going to put the part up there because I can see the center. And all that's just to get me kind of in the neighborhood, so I don't have to think about it. I don't have a DRO on this lathe, so it's somewhere out there. It's going to be good. And then I'm going to put one inside it a little bit, and I'll put one outside of it a little bit. All right, and this is going to be like the lines on your faceplate, or the lines on your four-jaw chuck, something like that. Okay. So all right, let's get that out of the way. Okay. Alright, well, it doesn't look too bad. Yeah. Okay, let's. This will go all the way across the screen. Alright, well, sometimes you get lucky. So this clamps, it can span across that hole. So what I'm going to do is I'll put one in the middle first, and just to kind of hold this thing up there while I'm getting the other clamps on there, and make my life a little easier. Use this middle hole here. And I'm just going to kind of get it close. I'm not really trying to get it deadly close right now. I just want to hold it up there so I don't have to. Oh yeah, that's pretty good. I can crap, that's not bad actually. So, okay, let me pinch that down a little more. So these are 1032 screws. You can actually clamp stuff pretty well with these. So anyway, that's the general idea there. It's gonna, I'll put some around the outside here to hold it down. And these have little heel screws here too, so that they hold up the rear of the clamp properly. So you're not coming down on an angle, which is bad news. Put this on here. Of course, that screw's not long enough. I'm going to play musical screws here probably. So. That one's too long, yeah, that one's too short, yeah. Unfortunately, these holes are tapped. Well, I faced over the top of it, and I probably should have. There it goes. Should have countersunk the ones I'm going to use, but normally you can get them in there, and you don't have to mess around. All right. That'll work, so I'm going to pull that way back like that. And bink, there's one. Go up there. Do another one. At least I know which screw to use now, right? Oop, I don't think it's that one. And hey, it didn't go in the chip pan, so whenever you do a job with little fussy parts, it's a good insurance policy to clear out your chip pan ahead of time. That hole's not looking too good. I gotta countersink the top of that. So it's a good in boy, you know, sometimes you're the goat, sometimes you're the worm. it's still looking a little peaked. So now I gotta re-tap it. Alright, well, you get a tap. This is just a forming tap. I didn't grab a cutting tap. I just, basically it's just the top thread's bent over a little bit and it just needed a little help. So, but nothing unexpected. Hey, look at that, it goes in there. Alright. Do that one there. I'm adjusting the little heel screws so they have the right offset for the thickness of this little plate that I'm working on. That'll make it. Keeps the edge there. Okay, so 4 is probably enough. They're kind of far. Well, the hole actually comes out. I don't know if you can see this line here. This skirt is welded to the main part here. So the hole actually kind of comes like that. So it comes into that area, so I got to stay out of that area. Yeah, it should be fine. We'll see how it behaves itself when I start machining that hole out. Might be one of those. I might have to turn the sound down, if you know what I mean. It's the kind of job in the shop that somebody's working on it and they're across the room squeaking away over there and you're just like, come on, finish that thing, right? And but gotta get done. Yeah, I should countersink these dang things. Alright, getting closer now. Alright, like that. Alright, not too bad. Plate's in there pretty good. Okay, so now those they're not tight, but they're not loose either. That one was a little tight. So I'm going to take this one out now, my center one. Now I can start looking at dialing that hole in. That hole is was in the part beforehand. I made these. These are a special clamp to hold a vessel for. Actually, it's for my dad. he asked me to help him out with a little project, and I built these a couple of months ago, and they got a different vessel that's larger, and they wanted to use the same setup. So I'm making a special one that's oversized. All right. So let me get an indicator on this thing. So I'm just going to get up close here with the pointer and just kind of look and see which way I really need to go here. Alright, so it's close in that direction. And far over there. Okay, so it looks like I need to tap it over that way. So I get a little punch and a hammer, and I can tap it over there. It's looking pretty good. What do I want to do here? Okay. You guys won't be able to see this, but that's all right. This will take a minute anyway. The hole's a little bumpy because it's laser cut. All right, so that's coming towards me, going away from me, coming towards me right there. Okay. So we're just gonna. Interesting here. Since there's no clean edge to tap on here, it doesn't necessarily want to move the way I want it to. Easy now. Get down to the those corners. It doesn't. Shit. What? What is it? 5, 10, about 15. Boy, that hole is kind of weird. I wonder if that hole's not that round. It's kind of what it looks like. Because there's sections of it that run actually pretty good, and then when it gets near the stop-start of that hole, well, that's pretty good, and then it starts drifting off. So I think that hole's not real round. Huh. Well, that's interesting. So let's pinch that down a little bit. I'm not going to use this boring bar. I just happen to have that one. I was doing a little tiny job a while back. But this will be, oops. Maybe all that welding on there took that hole. $767. All right. Oh, 771. Okay, yeah. So that's what's going on. This from that welding. Of that hole, it's the hole's egg shaped, so that's why it's giving me a hard time. And so the question is, well, that's where it's going to be. Well, most of the hole's pretty good there. I got no other good datums here to work with. That I can pick up on. Whew. It just doesn't. So it's out there, and then way the heck out there, huh? Well, what could work? Geez, I don't want to take that out again. Somehow I gotta like average that. Oh, you know what? I got something else here. So I scribing this, some layout lines on this thing, I made a little plug, and so I could pick up the center. And the you know what? That's not going to work either, is it? Because I don't know where it was. Anyway, I made this little spanner plug, and it's tapered slightly, and I drove it in there so it stayed in there, and then I could use it to put the dividers on so I'd have a center. But I was thinking I could use it to help me pick up the center of this. But I don't really know I don't know what the orientation was in particular, and the hole's egg-shaped, so it's not going to do me any good for picking up my center in this case. So the problem here is I need to average the error. So I think it's just going to be a bunch of indicating and horsing around there until I'm satisfied. So what I'll do is I'll mark some quadrants here. We'll start there. 1, 2, 3, 4, and so I've kind of lined them up with the general axes of the part. Well, it's out between 1 and 3. It's changed shape. That hole's not round anymore. So I'm going to get a little different indicator here that's not quite so jumpy. We'll stare at last word here. Flip it over. These things are they're pretty. They can run over some bumps and be okay. Where that inner rapid is much more sensitive to some of that rough stuff. Let's see. And this one's just on a little magnet, so I can stick it up in the lathe real quick. All right, so I'm gonna put the indicator tip kind of on center too. All right, that'll come out. And all right, let's see what we got. Yeah, see how that's. Okay, now it's going the other way. Going away from me there. Alright. Let's get the fine adjustment tool here. Oh, I'm tight still. You got 4 clamps, it's not quite like a 4-jaw. In a 4-jaw, you can just kind of dial it in on a faceplate. You're scooting around all over the place. So, okay, right there. It's almost like I got to lock one. Too loose. Okay, welcome back to Ox Tools. I'm Tom. Where we left off before was I was trying to indicate this plate in, but this hole is kind of egg-shaped and not cooperating. So what I decided to do is I just cut a little piece of 1/8 inch aluminum and bolted it to the plate, and now I'm turning it concentric with the machine, and I'm going to fit. It actually is really close to going on right now. I could probably just tap it on, but I'm going to take a couple more thousandths off of that. And what's that's doing is averaging that hole for me. So it's kind of a diameter that averages that mess, that distorted hole, which should work fine for what this thing is. So I'm going to take another couple of grand off of this thing. Just going to chamfer that edge just to give me a little lead in to help start. Alright, let's see what we got now. It's kind of, I don't know, sort of cheating a little bit, but yeah, there it goes. I didn't think about how I'm going to get that out of there, to tell you the truth, since it's kind of a snug fit. Maybe I ought to make it fit a little looser, huh? Yeah, I'm going to take a couple more thousandths off. Because I got to get out of the hole before I do the job. And, I don't want to make it hard for me. Okay. Now I can kind of rotate this thing around a little bit too and find a kind of orthographic with the square there. Well, that's how you do this stuff. You have a problem and then you go back and change your plan a little bit, and slowly hopefully you get better, right? Alright, so now I'm just going to crank this down, because it's as concentric as it's going to be with that hole, the way it is. Now we get another funky Otis hole there. Yeah, well, guess what? I'm armed with my tap here. I'm going to put 4 clamps on. That's what I had on before. I don't want this thing doing anything weird on me. And it's, I guess I'm a little worried that there's not one even close there. You know what? I'll use one of the long ones. I got two different lengths of these things. You know, sometimes if a hole's not close enough, you know, you can shift over and use the longer clamp. Just a little heel screw. Alright. Crank those down nice and snug. Don't look at that. I was wishing I had a hole right in the center, you know, that would have helped. But, you know, it is what it is. Alright, let's see if we can get that out of there. This ought to be interesting. Loose enough that it was gonna, you know, just go right out of there, but looking that way. I guess if I would have been thinking ahead, I would have put a little notch that, you know, that I could have got a screwdriver under there or something, but just kind of wanted to get the darn thing going there. Yeah, let's pick at it a little bit and see if we can. It's not going to tilt very well. You kind of need to, you know, just pull it straight out. That might work. So it's just it's a big sheet metal screw. Let me get a pair of pliers and give that a little tug and see if it'll come out. Yeah, okay, good. All right, something worked. Okay, so all right. Well, I got a little boring bar here. Maybe this thing will work. It's not a very big boring bar, but it's got a good insert in it. It's like seriously close to the universe there. All right, so that's 82. What am I on here? How about 300? neutral again. I always like to give things a little spin, not under power, you know, just to kind of see where things are. Okay, that should be. So that boring bar is too small. It's humming already. Like I said, I was doing a little job. Let me get a different boring bar. That one. Alright, something like that. Don't really want it hanging out any farther than it needs to be. This one's it's an inserted solid carbide boring bar. So it's a real rigid boring bar. The insert's trashed in this. Okay, it's got a good side on it still, so I'll just go with the flow here. You know, I got a long ways to go here, so this is a high positive insert. If I was just boring a little bit, then I'd say fine, but you know, this hole's going from 1.75 to 3.75, so it's going a long ways. You know, it's going to come out in this area, so that's a fair amount of material to zip off of there. So I'm going to get a more favorable geometry insert. This is a good one here. This is a Mitsubishi insert here for stainless. Mitsubishi makes some pretty good stuff. Okay. I'm gonna set my center height here. I'm right at the top here. This big lathe, you know, and most of my tools are not quite so gigantic, but so sometimes I got to put little riser shims underneath it so that I'm not right on the darn bottom of the height adjustment. Alright, let's see what we got here. That's better. call that happy. Looks like I got a little relief there in that direction. Ooh, not much. All right, I'm gonna swivel this tool a little bit. The end relief isn't the way I want it. Okay, that looks good. Okie doke. I think we're ready to try some boring here. Oh, feed that way, that way. Set a Z depth here, something like that. Leg hurts a little bit right now. Nice one to check something. I just wanted to check the cutting speed. Those inserts say 475 surface feet per minute. Well, I'll tell you what, I'm not going 475 surface feet per minute, so we're going to be less than that, around 200 feet per minute. 3/16. Yeah, long ways to go. That's behaving itself. Yeah, it's gonna be boring. So I'm gonna turn the video off. I'm gonna bore some more, and then when we get a little closer, I'll turn it back on for the finished bits. Okay? All right. I'm Tom. This is Ox Tool. See you in a little bit.